All right, here we go. Question 13 from our Precalculus homework number 2. In my lab math, they have given me a quadratic function, f of x equals 2x squared minus 3x plus 2. They want me to find the vertex first. So we're going to need to identify the values for a, b, and c. And then we can find the coordinates of the vertex h and k. H is minus b over 2a, which in this case would be minus negative 3 over 2 times 2, and that's going to give us 3/4. Once we know h, in order to find k, we're going to have to evaluate the function at h. Plugging into the function, we're going to get 2 times 3/4 squared minus 3 times 3/4 plus 2, and then using our handy dandy calculator, 2 times 3/4 squared minus 3 times 3/4 plus 2 equals 7/8. So 7/8 is the y-coordinate of the vertex. And now all we need to do is input that as an ordered pair. 3/4, 7/8. Make sure that that is input correctly, and we're going to check it. Now, for the equation of the axis of symmetry, that is always x equals the x-coordinate of the vertex. Fantastic. Is the graph concave up or down? Well, since A is positive, that means it's going to open up, which means concave up. Next part, they ask us to find the x-intercepts, if any. The x-intercepts occur when y is 0. So we're going to set our quadratic function equal to 0 and solve the quadratic equation. Now what I'd like to demonstrate this time is solving the quadratic equation using the quadratic formula. So we're going to have to identify a, b, and c, and then plug into the quadratic formula. That is negative b, since b is already negative, that makes it a positive b, plus or minus the square root of b squared, negative 3 squared is 9, minus 4ac. 4 times 2 times 2, all over 2a. And then we need to simplify. 3 plus or minus square root of. That's going to be 9 minus 4 times 2 is 8, times 2 is 16. At this point, I can stop because I notice that the number under the square root is going to end up being negative, and that implies no real solutions, which also implies no x-intercepts. So we're going to choose no x-intercepts. Yay. And the y-intercept, that will always exist, and that will be at the constant. That is a shortcut you need to know. Choose the correct graph. None of these graphs cross the x-axis, so all of these are still valid based on the x-intercepts. If I blow these up a bit and take a closer look, answer choice A has a y-intercept of 2. Answer choice B and C do not. So B and C are out because of the y-intercept. Answer choice D has a y-intercept of negative 2, and that's also out. So by the process of elimination, based on the y-intercept alone, we know the answer choice is A. Part D, find the domain and the range. Now they do want the domain in interval notation. I'm going to use the ordered pair tool. Even though the domain is not an ordered pair, it is the interval from negative infinity to infinity, because the domain of every quadratic, well, and in general, the domain of every polynomial function is always all real numbers, which is negative infinity to infinity. And the range from bottom to top, if we go back to the graph that was correct, we know that the lowest point on the graph was the y-coordinate of the vertex, and the y-coordinate of the vertex was 7/8. So the range is going to be from 7/8 to infinity, and the 7/8 is included, so it needs to have a bracket. In interval notation, that is going to be everything from 7/8. Did I make it clear that that is always the y-coordinate of the vertex? To infinity. Infinities always get a parenthesis. And again, the infinity is on the right because the graph opens up. It's going to go up to infinity. Next, part E, determine where the quadratic function is increasing and where it is decreasing. First, the interval of increasing. I have redrawn my graph over here to illustrate how to find these intervals. The first thing we need to do is draw in the axis of symmetry. That is the line that cuts the parabola in half. We know that this vertical line occurs at an x-coordinate of 3/4. We can tell by examining the graph that it is decreasing from negative infinity up to this value, and then it will increase from 3/4 to infinity. So we can see, based on this picture, that the interval of increasing is from 3/4 to infinity. Remember that increasing, decreasing, and constant intervals never use brackets, only parentheses. 3/4, comma, infinity. So there's our section of increasing. Our section of decreasing is going to be from, and again here I'm using the ordered pair tool, from negative infinity up to 3/4. And let me say it this way, when you're finding these endpoints of your increasing and decreasing, that value always comes from the x-coordinate of the vertex. So here we go, from minus infinity up to 3/4. And again, just to make sure you've heard this, that the intervals have to be represented from left to right. Next, for part F, they want us to determine where f of x is greater than 0 and where f of x is less than 0. So we're going to have to select the correct answer choice. If you look over here at the graph, remember that f of x is y. So what we notice from our graph is that the entire parabola occurs above the x-axis. So all of the y values for every ordered pair on this graph will be positive. Since they're above the x-axis, this entire graph is greater than 0. None of the y values are below the x-axis, so there is no part of this graph where f of x is less than 0. So if you look at answer choice A, it says f of x is never negative. That is correct. There are no y-coordinates on this graph that will have a negative value. F of x is always greater than 0. And then they want the interval notation. Since it is all real numbers, it's going to be everything from negative infinity to infinity. Whew, and that's going to do it for that particular problem. So if you have any questions or comments about anything that I've covered, please feel free to leave those in the comment section below, or you can text me, and thanks for watching.